Okay.
Oh, sorry, it's forward.
All right, so Monty has a question, so we'll start with Monty, and then we will go to the rest of you. Okay, anybody else that has a question? So Monty, what kind of question do you have?
I think it's on the last page. I don't know. It's question number 32.
Honey, just read the question to me.
Oh, it says a box is open.
All right, so this is one of the box problems. So we're gonna have a box problem. So we're gonna have a piece of paper that's maybe let's say 24 by 19. So we have a piece of paper that's 24 by 19. We're gonna cut the corners out, and we're gonna make a box. And our ultimate objective is to make the biggest box that we can. We want to maximize the volume of the box. So the questions that you're going to have to address here, the things you're going to have to write down, you're going to have to write down an equation for the volume of the box. You're going to have to tell what's the domain, which is going to be extremely important because that's how you're going to set your window up when you graph this equation to find either the size of the corners or the maximum volume. I did change the problem a little bit on the exam for the other teachers. They weren't happy with some of the stuff, so the only things you're going to have to answer, what's the equation for the volume, what's the domain, and then either what are the size of the corners or what is the maximum volume. So, paper is 24 by 19. Volume is length times width times height, right? So what goes in those parentheses? We need three things, length, width, and height. What goes in there? 24 minus what? 2x. You're taking a piece off each end. So 24 minus 2x, 19 minus 2x, and x. What happens over and over again is sometimes we forget the x. That's why I put three parentheses down here and say to myself, length times width times height, to remind me that I should have three things. Sometimes we get these turned around and say 2x minus 24. That is wrong. It doesn't even make sense. It's 24 take away 2x. So make sure that your equation is set up with dimension minus 2x, dimension minus 2x times x. Now, what's the domain? Well, the domain is always x between 0 and something. And the something is always half of the smaller of these. So 19, half of 19, 9.5. So when I go to my calculator to graph that equation, this will be x min, right? This will be x max. What will y min be? Always, y min is 0. And then y max is the one you're going to guess. 1200? I have no idea, so we'll go with 1200. It's a guess. Is there just one correct guess? No, there are lots of guesses, right? How do we know we have a good guess? No. What do I have to see when I hit graph? I got to see the top of the hill, right? So if you don't pick a high enough number, you might not see the top of the hill. What'd you say, 1200? All right, so I'm going to type in the equation. Haven't done that yet. Oh yeah, that was a good guess. So now I can see the top of my hill. So now I'm going to maximize it. So second calc, down to max, because I want a maximum. Then I'll set my left bound and my right bound. now I'll get a maximum point of 3.51, 714.01. So there is my maximum point. Now, depending on the question that's asked, either 3.51 will be the answer or 714 will be the answer. If we want to know the size of the corners, then we want to know X, right? So that would be 3.51 inches. If we want to know the actual volume, that would be the Y value, or 714.01 cubic inches. So you're only going to answer one of those questions. It just depends which test you have or which answer.
This works. Can I see your calculator?
No.
I want to see what graph you got, because mine looks good.
Well, yours might look different depending on the Y max that you picked. That's fine. You just want to see the top of the hill. Yep, you just want to see the top of the hill.
Second trace, right?
All right, who else? Emma.
I have a question for the so if it says find the nearest 0.01 inches.
That's nearest hundred. Size of the notch, that's X.
Okay. Thank you.
0.01 would be 100.
As long as you can see the hill, it's fine.
Yep. It's the top of the hill, yes. Do you have an equation in there? No. Press Y equals. Do you have an equation in there? Honey, you gotta have an equation to graph. You gotta put that equation in if you want to graph. Yeah, that's probably, yeah. All right, we'll let that go. KJ?
So this is 20% of our grade?
Yes.
How many questions is it?
It's just like the review guide.
Okay.
So, review 1, the problems are kind of mixed up. Some of them are starred because they're calculator. If you look at review 2, they're in order. So the whole first chunk is no calculator, and then the second chunk is calculator, just like the exam will be. All right, so who else has a question about one of the problems? Jordan? Just tell me what the problem says.
I just saw it saying the item is marked at $8.20 in the store.
Okay, so I'm going to the store and I'm going to buy something, and it's going to cost me, let's say 36, or let's say the price tag says $36.50. So I walk into the store and the thing that I want costs $36.50, but the store is having a big sale and says it's 30% off. So there's a 30%, everything in the store is 30% off, but I know I live in Indiana, so I have to pay a 7% sales tax. So the question is, how much am I actually gonna have to pay for this thing? This is what the price tag says. There's a 30% discount in the store, and I gotta pay 7% tax. So, the 30% discount is off of 100%. So 100 minus 30 is 70%. So I'm gonna multiply by 70%. And then this is 100 plus 7, so I'm gonna multiply by 1.07. Remember, if it's a discount, you subtract it from 100. If it's an add-on, you add it to 100. So we're just gonna take 36.50 and multiply it by 0.7 and 1.07. And I'm gonna pay $27.34 for this. So whatever the discount is, Jordan, you multiply by 100 minus it. Jordan, you paying attention? And then whatever you're adding on, it's 100 plus that. We just type it in and we're moving on. All right, who else has a question about something? Mikey, no hoods in the building, sweet pea. All right, who else? Somebody has to have a question. Ian. Yeah, we can do a couple properties. Now, there is only one property question on the test, but there is one on the test. So the properties we ought to be familiar with, let's see, let's not use all letters. Let's just see numbers. So here's a property, and here's a property.
Yeah, I know. It's a rough morning. I thought you wait till AP final.
And here's a property.
We got 650. Like 80. It still was late.
Alright, so here are some properties. One of these will be on the test. It's a multiple choice question, I think. So here we go. What's that up there on top? What property is that? That's distributive. Everybody knows that one, right? That's kind of the easy one. You've all been distributing since you were younger kids, so you know that property well. Now,
Identity.
that's called the reflexive property, but that isn't what I meant. This is what I meant. There we go. That's what I meant. What property is that? I'm hearing
That's not
commutative and I'm
Commutative
hearing
is
associative.
It's the third one, isn't it?
That's associative of multiplication. The associative property, now listen, the associative property associate. When you associate yourself with people, don't you group yourself with them? Aren't they part of your group? If you are dealing with grouping, it is associative. 4xy, 4xy. The only thing that's different on these two sides is the way we have associated, the way we've grouped the numbers. This is the associative property. Now, this one looks a lot similar, but notice, aren't the same two things grouped? What changed here is the order. That's the commutative property. When you commute, you move. X and Y moved. When X and Y move, it's the commutative property. That's the commutative of multiplication. You gotta, it's time for you to get these two straight, okay? Associative, nothing moves except the parentheses. You regroup. Commutative means things actually flip spots. What property is this? That's the additive identity. Yep, that's the identity. If you add 0 to something, you get that something back again. What's this? And that's not an identity. The identity would look like this. 4 times 1 equals 4. That's the identity. If these are canceling each other out, that is an inverse property. So if you had 6 plus negative 6 equals 0, that's an inverse property. They're canceling each other out. So you might want to spend a little more time looking those over, making sure you've got those all figured out. One question. One. All right, who else has something to talk about? Jordan?
Can you, synthetic division, like here on?
Okay, so the problem says, what are the possible rational roots? And then find the actual roots. So finding the actual roots can be a synthetic division problem, although it doesn't necessarily always have to be. So let's see here. Alright, so let's say our problem is, oh wait, I gotta read this, sorry. So let's say we have 2x squared, or 2x cubed, plus 6x squared, minus 8x, minus 22. Oh gosh, I hope I did that right. We'll find out here in a minute. So the PRRs, the possible rational roots. So on the test, it's going to say possible rational roots. You need to recognize that's what we've been calling the PRRs. Possible rational roots. Factors of 24, oh gosh, there's a lot. So that would be 24, 12, 8, 6, 4, 3, 2, and 1. All the factors of 24, did I get them all? Yeah. Okay. Over factors of 2. Remember, the PRRs are factors of the last number over factors of the first number. Okay? Now, you need all the combinations of this. So let's pretend that's not there. That would just be those numbers, right? 24, 12, 8, 6, 4, 3, 2, and 1.
Wouldn't it be 3 over 2 would be?
Okay, but now I gotta go back. So if that's not there, that takes care of those. But now I gotta put them all over 2. Well, 24 over 2 I already have. 12 over 2, 8 over 2, 6 over 2, 4 over 2, 3 over 2 is a new one. And 1 over 2 is a new one. So there are the actual PRRs. Taking all the factors of 24 and putting them all over the factors of 2. Those are the PRRs, that list, done. You only have to put 1 plus or minus. You don't have to put plus or minus on everything. Now, the second part of that question says, find the actual roots. These are the possible rational roots. So if you want to use synthetic division, this is the list that you would pick from. So when you pick a number and divide it out and hope that you get 0, remember that? This is the list that you pick from. So it's a very big list. But this is the list of numbers you choose from. Some of you are going to look at the problem, though, and say, yeah, I know I could do synthetic division, but I don't have to. Because why? It groups. It groups. So if you notice that it factors by grouping, so we'll take out a 2x squared and be left with x plus 3. And then I'll take out a negative 8 and be left with x plus 3. See how that works?
Yep.
So you can do it either way, and I'll do it the other way here in a minute. You don't do it both ways. Whatever way occurs to you and works for you. Be on the lookout. Factoring by grouping is a fine choice. But they don't all group. This one does. So now I have my common factor, so I write it down. And then I have what's left. Now, what do you notice about the part that's left? You can take out a 2. So I'm going to take out a 2 and write it out here in front. Okay, so I took this 2 out and put it out here. Now, what do you notice about that? That's x plus 2, x minus 2, right? Now, what are the actual roots? Remember, these were the possibilities. What are the actual roots? Negative 3, negative 2, and 2?
Yeah.
You
So-
said 0
Why would you say 0?
because of the 2 out in front.
No, there's no x there.
Okay.
Keep in mind, Monty, how many answers does this problem have?
Oh,
3. I got them right there. No more answers. Now, if I factor out an x, if I had an x out here, then that would be a 0. But it's just a number, so it doesn't give me a root. So, let's say, okay, you got to find the actual roots, and you don't notice that it factors. or you don't know how to factor, or it doesn't factor. So you're not factoring. What would you do? Well, you would look at this list of numbers and you would pick one. Now, personally, I always start with 1 and -1, but I'm not going to start there because I already know what the answers are. So you're going to pick a number. Let's say you pick 2. So you put 2 out here and then do your division. And if you have guessed right, you know what's going to happen, right? What's going to happen is right here. You get a 0. Then you have to take what's left, which is 2x squared plus 10x plus 12. And you have to factor that, or solve that. It does factor. If I pull a 2 out, I have x squared plus 5x plus 6. How does that factor?
X plus 1, X plus 2.
No, that would give me a 7 here.
3.
So that'd be 2 and 3.
Oh, it had to be 5 and 6.
2 and 3. Okay. So I guessed 2, and then this would give me -2 and -3. So do you see how you're going to get exactly the same answers? There's 2 different ways to do it. Doesn't matter which way you do it. It's a free response question. So you'll get a chance for partial credit if you make a mistake somewhere along the line. Okay? We're going to lunch soon. Is it an absolute emergency or can you wait a few minutes?
Okay.
Huh?
I can wait.
Okay. This is the lunch period, correct?
Yes.
I'm glad you're honest. Would you have said yes even if it weren't the lunch period?
No.
Yeah.
All right, who else has a question? Let's get a couple more in before we go to lunch. Couple more questions.
Oh, he's not feeling good today. What's wrong, Jordan?
You need to go see the nurse? Okay. All right, who's got a question for me? Kenzie, you got to have a question somewhere. Yep. We know there's a mixture problem on the exam. How do we know there's a mixture problem on the exam? It's on the review sheet. I can't emphasize that enough. You need to know the review sheet. All right. So, how much 15% to be mixed? I'm leaving out some of the words to go faster. How much 15% to be mixed with 90% to get 12 gallons of 62%?
You gotta do parentheses to double.
Yes, so the first thing you think about is the structure of the problem. And the idea is we've done so many, you should immediately be thinking, I need an amount times a percent plus an amount times a percent equal to an amount times a percent, right? So parentheses, 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 parentheses. You don't have to write this out. I ought to see these parentheses though, because this is how you do the problem. You have to have stuff in those parentheses. And what goes in those parentheses are the percentages. So the first one is 0.15, the second one is 0.90, and the last one is 0.62.
12 goes with 0.62.
See this number right here?
Yeah.
That has to be matched with whatever percent it goes with, so it's over here. See these 2 words right here? That's X. How much? 15%.
And then 12 minus X.
And then my empty parentheses is in the middle of the problem. So when it's in the middle of the problem, it's 12 minus x, right?
Right.
Sometimes the empty parentheses is over here. And then it would be 12 plus x. But when it's in the middle, it's 12 minus x. So then we can use our calculator. This is a distributive. I'll show you. 10.8 minus 0.9x equals 7.44. Okay, now these two get added together. They're on the same side of the equation, so that's or subtracted. So that's going to be, watch it. What is that? .15 minus 0.9 is negative 0.75. Oh, I still have the plus 10.8 equals 7.44. So now I'll move that 10.8 over. So 7.44 minus 10.8. So negative 0.75x equals negative 3.36. Now I'll divide. And I got 4.48 gallons.
Good to me.
Okay, I use my calculator to help me with all the arithmetic. That's a calculator problem. All right, let's have another one. Christian, you got any?
Surprise me with one.
Okay, I can do that.
What do you say?
Surprise me.
Oh, heck yeah.
But we laughing about something totally different.
Why are we laughing? Shouldn't we be paying attention?
This mathematics makes me happy.
It does make me happy. All right, here we go. Question says, what are all the asymptotes? List all the asymptotes. So we're going to have horizontal and vertical asymptotes. What are all of the asymptotes? The asymptotes are equations, remember? Horizontal asymptotes are y equals and vertical asymptotes are x equals. So here we go. What are they?
Break up the bottom.
We're going to break up the bottom, factor the bottom. So that will be x minus 7 plus 1. And what does that tell me? My vertical asymptotes are x equals 7 and x equals negative 1. Vertical asymptotes happen where the denominator is 0. So whatever makes the denominator 0 is going to be a vertical asymptote.
Y equals 9.
0.
Y equals 0.
Oh,
And why is my horizontal asymptote y equals 0? Because the x on the bottom, x squared, the power on the bottom is bigger. When the power on the bottom is bigger, the horizontal asymptote is 0. If this had been a 3x squared, then the horizontal asymptote would be y equals 3. Right? But since they didn't match, we have to look at which one's bigger. And when the one on the bottom is bigger, the asymptote is 0. If the one on the top had been bigger, so like if this had been a cube, then there would be no horizontal asymptote. If the one on the top is bigger, we have what's called a slant asymptote, which we didn't talk about yet. So just no horizontal asymptote. But ours was x over x squared. That means the asymptote's at 0.
So you're not going to give us one exam where the exponent on top's bigger, are you? You said we didn't talk about that?
No, we did talk about it, the fact that there's no horizontal asymptote. So you would just have the two verticals. What we didn't talk about is, what is the asymptote? It's not horizontal, it's slant. And we didn't talk about how to find the slant asymptote.
Oh, okay.
Miss Ford, when you're doing like an element once you solve it for number 22, it's like you put the
What does the problem say?
and then it's exponent 3x minus 1 equals 5.
Okay, when we come back from lunch, we are going to start with a problem like this. Solve e to the 7x plus 1 equals 10. We're going to start with that. I need you back from lunch. Oh, whoa, hooligans. Ho. Yes, hooligans. I need you back from lunch at 51. 51 sharp. 51 sharp.
I just want to let you know,
You can eat in here as long as there's more than one of you in here.
I just want to let you know so that.
Is someone else gonna stay in here and eat?